As I mentioned before, another name for residual is called the error, and it tells us how far our predicted value is from the actual value that we observed. Okay, so that's why it's an error. Sometimes it's helpful to find the total error for a regression line because that tells us how good of a fit it is. But we can't just add up all of our residuals. Take a look here at the calculator. Notice that some of them are positive and some of them are negative. So if I just add these all up, I'm always going to get 0 or something really close to 0 every time because some of the dots are above and some are below. So to avoid that problem, what we do is we square all the residuals and add them up. Okay, we call that the sum of squared errors, SSE. Okay, so we want to do this from our data that we already have in our calculator. So what we want to do is take all of those residuals, square them, and add them up. Okay, so what you're going to do is you're going to go into L5. We're going to type it down here where it actually makes sense. So we're going to go into L5 and we're going to take all the residuals. Remember, those were in L4, and we're going to square them. Okay, so let me get to that on the calculator. Edit. Okay, go over to L5, and you're going to tell the calculator that you want L4 squared. So that's just taken all of our residuals and squared them. And now we want to add them up. So, I mean, you can add those all up by hand if you want. The way to get the calculator to do it is to go to your stat menu, go to calculate, and run one variable stats on L5. Okay, let's make that smaller so I can actually. Okay. All right, so go back to stat, calculate. The very first thing is one variable stats. Mine's an older calculator, so yours may look a little different here. But I'm going to tell it that I want to run one variable stats on L5, and then it's going to do that. And remember, what I was looking for is all of them added up. Okay. So you are looking for this guy, sigma x. That means all of your x's added up. So that is going, so that's the one you're looking for. I know that's not a Greek letter. That's going to be your sum of squared errors. And in this case, it is 1.39. That look good? 1.394. Yep. Okay. So that is how you find that. Now, something else that we calculate with this is called the standard error of estimates, S sub E. It measures how much the sample data points deviate from the regression line. So it gives us another number that shows how far away all of these points are on the scatter plot from the line. Think of this as like standard deviation. It measures how much the data deviates from the mean, but instead of from the mean, it's how much does the data deviate from the line. There's a fantastic formula. Here, it's the square root of the sum of squared errors divided by n minus 2. So we can definitely do this by hand, and then I'll also show you how your calculator does it. Since we just did this, let's see how good I am with the pencil. So that's going to be the square root of our sum squared errors, which we just said was 1.394. I have to use my mouse for this. It's taking forever. I'm on a touch screen right now. All right, and then divided by n minus 2. N is just the number of items in our sample. There was 10, so we're going to divide that by 8. And then we'll just plug it into our calculator and see what we get. 4174. All right, and with just about everything else that we have, the calculator is going to do this. If you've got this in here, remember how I said our linear regression t-test is fantastic? So go back to that stat, tests, and run a linear regression t-test again. And I'll show you what we're looking for. So stat, test. If you scroll up, you'll get to it faster. Linear regression t-test. Remember where L1 and L2 is where all of the original data is. It's always the not equal. Doesn't matter if we store it this time, whatever. Okay, and what we are looking for in this list is S. Right there it is. Okay. So when you run that linear regression t-test, that's why we love it so much, because it gives us so much wonderful information. Exactly what we calculated before is that S is our kind of like a standard deviation. Okay, so our predicted values vary from the actual values by about 0.4 on average. Okay, now what we can say about this is, since this value is close to 0, we can conclude that the data points do not deviate very much from the regression line. Okay. If your S value were large, like 40, then your data might vary a lot. Okay. We'll check out some more stuff about linear regression in the next video.